Okay, we're going to talk about conversion. And what conversion is, it's an operation that you can do to a categorical proposition, and that can produce logically equivalent statements or statements that are not logically equivalent. Okay, and you'll get a better idea what the operation of conversion is when we go through it. But we're going to do conversion, so we're going to convert statements, convert an A, E, I, or O. And then we're going to go into obversion in some other videos where we will obvert statements. And then we will do contraposition where we'll take the A, E, I, and O and we will contrapose those categorical propositions. Okay, so what they are is conversion, obversion, contraposition. They're three operations that can be performed on a categorical proposition, an A, E, I, or O, resulting in a new statement that may or may not have the same meaning and truth value as the original statement. Okay, so what we're going to do right now is conversion. So some of the practicality here is, let's say you have a statement that's converted. It looks a little different, but if you realize it is equivalent to an A, E, I, or O, let's say something like that, it's equivalent to a regular categorical proposition, and you can do some neat logical moves with the A, E, I, and O, and you have a statement that if you convert it, or you realize it is a conversion and it's logically equivalent, well, there can be times when that is just a good thing to know, and it can be helpful in some other applications, okay? Plus, this is very, very good for your brain to understand how to do this, to be able to figure it out, and we're going to do some Venn diagram tests with this. You can tell by doing Venn diagrams if a statement, once it's converted or obverted or contraposed, is equivalent or not. Okay, so you remember last video I showed you how to do Venn diagrams, and you're going to see that they're going to have some application here. Okay, so let me read this again. There are three operations that can be performed on a categorical proposition, resulting in a new statement that may or may not have the same meaning and truth value as the original statement. When it does have the same meaning and truth value, that means the converted statement, the new statement, is logically equivalent. Okay, so we have a rule here with conversion. Okay, if you're going to convert an A, E, I, or O, it's just a basic rule here: switch the predicate and subject term in the four categorical propositions. So you're just going to switch them. Okay, and I'll give you a heads up: when you switch or convert the E and I propositions, you will have the same meaning preserved, so the same truth value. If the E proposition is true and you convert it, the conversion is going to be true. If the conversion is not true, like it's false, then you know it's not logically equivalent. But for E and I, if they're true and then you convert them, they're still true. And I'm going to show you this by just doing it with simple English propositions. You'll see that we'll say, is this true in English? Yes. If we convert it, it's still true. It has the same meaning. And we're going to draw the Venn diagrams for the converted statement, and it's going to match the Venn diagram before it was converted. So all of this is going to make a lot of sense as we get going here. And then A propositions and O propositions are not logically equivalent. I'll be able to show you that through the English sentences, and the Venn diagrams will be different. Okay? So with that, let's go. Let's start with the E and the I. I know I normally go with the A, E, I, and O, but we'll start with the two that are logically equivalent. Okay, so let's do E propositions. No A or B, and if you convert no A or B, you remember you just switch the subject and predicate terms. So, I wrote it there, but if you have no A or B, right, the conversion is you switch the subject and predicate class terms, switch the predicate and subject terms. So that's why you would write no B, R, A. Okay, so that's pretty easy. Conversion is just switching them. So that's what's happened here, and you've got to realize this is an immediate inference. They're logically equivalent, but an immediate inference is if you have one premise and you are allowed to make an immediate inference to a conclusion. So really, we could write this as an argument here. So let's see. If we had no A, R, B, right? We convert it, and here's the conclusion. No B, R, A. So really, this is like an argument, okay? If premise 1, we can call that premise 1. If premise 1 is no A or B, and you switch it to no B or A, that's called an immediate inference. It's a very short, pithy argument, okay? Now, there's two ways to test this. And notice I'm using A or B instead of S and P, right? I'm using A as the letter we're using for the subject term, B is for the predicate. The book was doing that, so I'll do that. But this could easily be S and P. Okay, so A and B are our variables. There's two ways to show it's logically equivalent, this E statement. No cats or dogs, we'll use English sentences. No cats are dogs. Is that true? Of course, that's true. Let's convert it. Now we have no dogs are cats. Is that true? Yes. So it's the same truth value because the meaning is preserved. We can just tell by saying it. So that's one way we know the conversion is logically equivalent. The other way is to do a Venn diagram. So let's go to our Venn diagram sheet here. And you remember, let's see, we had no A, R, B, and here's the A class, and over here is the B class, right? And then if we're going to convert it, that would be no B R A. Now, here's the thing you've got to be very careful about. When you convert statements, you leave the Venn diagram the same. This is still A, and this is still B. You don't write B here and A there. You do not switch the classes. We're only trying to decide if when you convert the proposition, if it's the same, you want to keep everything else equal, okay? So rule, I'll write this down here. Do not change up the class positions, okay? So if the subject term is over here, A, and the predicate term is representing this circle, you leave it the same, okay? So if we were going to, and I'm going to show you why in a minute, if you change them up when we get to something that's not, or maybe I'll even do it before, but let's do this one first, and then I'll tell you why down here. Here's why. Here's why you don't change up or switch, okay? But first, let's just go here. Okay, no A, R, B. That means you're not going to have any A that's also a B. It's an E statement, right? So we already know this one. You shade in here, right? No A or B. Here, what you're saying is you're not going to have any B that's an A. Okay, so remember, you haven't switched these. You write that in there. And lo and behold, it's the same exact Venn diagram. They match. Same diagram, right here, logically equivalent. And if we go back here, remember, the English sentence was the same also. So the Venn diagrams are the same, and no cats or dogs is true is equivalent to no dogs or cat. So again, you can tell by the English propositions, you convert it, it's the same, and when you go back to the Venn diagram, it is the same as well. Now, why don't we, before I go to the O, let me just illustrate why you don't want to change the classes. And let's go down here so we're not in the way. Okay, let's do something like this. All A, R, B, and here, this is the A proposition, okay? I'm going to jump down to the A. All A or B, this is not logically equivalent. And over here, let's convert this. This would be all B are A. Okay? So, let's go back, and now this is not equivalent. Let's first go back to the A proposition and do the English sentences. Okay, so I'm going to come back here. If we jump down to the A, they do not yield equivalent statements. Okay, you're converting it, and you call it illicit conversion. It's a conversion that doesn't produce something equivalent. All A or B is not equivalent to all B or A. So if you had this as a premise, all A or B, therefore all B or A, that's an invalid, that's not an immediate inference, it's invalid. And here's why. Let's say you had all cats are animals. Okay? All cats are animals. Is this equivalent if you switched all animals are cats? No. All cats are animals, that is true. But if you convert this, all animals are cats is false. So let's go back to our diagram here. We'll come down, and why don't we just call this A is cats. We'll call this cats, okay? And we'll just use cats here. And B is animals. Okay, we're just going to change this up. Here, this is going to be animals, and over here, it's going to be cats. So all cats are animals, and this is an A proposition. So we're going to make this the cat class, right? It stays there, and over here, this is going to be the animal class. All right, so if we have all cats are animals, that means, just like the A proposition, this is going to be shaded because it's empty. If every cat is an animal, you're never going to have a cat that's not an animal. So you remember, that's how we diagram the A proposition. All right, now we've changed this. All animals are cats. We already know that's false. But let's say we changed the classes, and we made this animals, and over here this was cats, because we think, well, if we convert, we need to change, we need to switch these things around. You remember I told you don't do it. Here's why. When you switch them around, if you're going to write all animals are cats, then this would be empty, right? Okay, and here when you look, it looks like these are equivalent because the diagrams are the same, but they're really not the same because we switched these classes. And what it's producing is, it looks like you have similar Venn diagram, and if you weren't aware that these had been switched, and you know these are in a different order, if you just looked at the Venn diagrams, would say, oh, I guess these are equivalent statements, but we already know they're not. All cats are animals, that is true, but all animals are cats, that's clearly false. So that's why you don't switch. Now if we came down here, and now let's draw this without switching it. Okay, so let's come up. We'll erase this now. Let me get a bigger eraser. All right, we're going to erase this. All right, now let's keep this has cats, like I told you we needed to, and animals, right? So here, now we have all animals are cats, right? We've switched that, but we haven't switched the classes. So when we say every single animal is a cat, that would mean this is empty on this side. And now we can see the Venn diagrams are not the same. It's not equivalent to match up the English propositions. So you see what happens? If you switch it, then it's really not an equal situation. We just want to look at the proposition itself. The only way to isolate that proposition is don't switch stuff. When you switch stuff, something can look like it's equivalent because the Venn diagrams are the same. They're really not, because we already know from the English sentences this shouldn't be equivalent. So the Venn diagram shouldn't be looking the same. Okay, so hopefully you were able to follow that. Let's go back up. And in a sense, you know what we've done? We've done the E and we've already done the A. A's not equivalent. You know why you don't switch the class positions on the Venn diagram. Let's go to the I now. This one is equivalent. You remember E's equivalent and so is I when we convert it. So here we have some A are B, therefore some B are A. Okay, this is an immediate inference, and here's why. Some writers are women. Is that true? Yes. Some women are writers. That's true also. So it's equivalent here, so when we do the Venn diagrams, they should be the same. So let's just erase everything here. Okay, let's clean this up, and we'll do this for the I. Okay. Okay, get this all neat, and now let's go up and do the I. Okay, here's the I right here. And let's see what we had for the I. We had some women are writers. So let's just go with these class. Some women are writers. So what we're doing is we're doing the second test. The English sentences we already know, some writers are women and some women are writers. I'm sorry, this should be some writers are women. So let me go erase that here. That should be... All right. So some writers are women. So the subject class will have writers here, we'll have women here, and remember on this one it's still going to be writers here, women here. Do not change the classes. Now if we were going to convert this, that would be some women are writers, right? Okay. So some women are writers. There's at least one writer that is also a woman. So you'd put an X in there, right? Here, let's go over here. Keep the classes the same. Don't switch them. You already know that. Here we have some women are writers. There's at least one woman that's also a writer. So you put that in there. You see the Venn diagrams are the same and these are logically equivalent. Okay, let's just do the last proposition now. And I think it would be the O here. We've done the E, we've done the A, we've done the I. Yes, let's go to this handout here. Okay, now we have the O. The O does not yield equivalent statements. Elicit conversion, it's conversion that's, it doesn't work producing the same, a converted statement that's got the same meaning. And so if we have an argument, premise 1, some B are not A, is not equivalent to some A are not B. Okay? And we can tell with the English first, some animals are not dogs. Is that true? Yeah. There's animals that are not dogs. There's at least one animal that isn't a dog. Okay? What about a cat, a horse, a pig? Okay? Now if you convert this, dogs are the subject and animals is the predicate term. Now you have some dogs are not animals. That's clearly false. So some animals are not dogs is true, but some dogs are not animals, that is false. So let's do the Venn diagram, and you guessed it, the Venn diagram should not be the same. So let's go down here, and let's just scoot this down. Go here. Okay, we got an O proposition. And we're going to say here some animals are not dogs, and that's true, right? Now let's keep the subject as animals. That's going to go here. Dogs is going to go here. We're going to do the same here when we convert it, right? Over here, and we're going to have dogs over here. Okay, that should, well, let's see. Let's make that a D. Okay. D. All right. So some animals are not dogs. There's at least one animal that's outside the dog circle. Okay, so we put an X there, right? Now if we convert this, some dogs are not animals. All right, let's do this Venn diagram. There's at least one dog that's outside the animal circle, so the X goes there. You see, these are not the same. It is not equivalent. Okay, so that's how you do conversion. And what you can do is if you go to the end of section 4.4 in your text, okay, so if you're in 4.4 in the 11th edition, it's page 224, but if you go to the end of 4.4, you're going to see a chart here, okay, and it'll talk about conversion. It'll say the E and I statements are logically equivalent, the A and the O are not, and remember we could tell two ways. Just do the English sentences, convert them. How do the English sentences read? Is the meaning preserved? No. If you have true, true, it's logically equivalent, but if you have true, false, you saw that they're not. And the Venn diagram matched up. Okay, the Venn diagrams were the same. Those where it was not true, true, but it was true, false, the Venn diagrams were different, provided you do not switch the subject and predicate class positions. The Venn diagram stays the same. If you have the subject animals over here with the categorical proposition, when you convert it, you still keep the subject there. And we saw with that when you do that, the ones that were not logically equivalent, we could tell by the English propositions, the Venn diagrams were different. But if you switch the subject and predicate position, I gave you an example with the A statement that the Venn diagrams looked the same, but that was misleading because it really wasn't the same diagram. Okay, our next video will be on obversion.